Okay, so we're graphing lines today as a review, and we're going to go ahead and solve a system of equations and tell ourselves a couple things. Is there only one solution, no solutions, or infinitely many solutions? And that's our goal today. But let's go ahead and start off with graphing lines. And the easiest way for us to graph lines was in this format: y equals to mx plus b. This was called slope-intercept form. And in our little Kahoots that we played yesterday, this was one of the questions, right? Y equals mx plus b was what we call slope-intercept form. And we call it a slope-intercept form because two characteristics are here. The m stands for our slope. How fast is this graph changing? What is the rise over the run? How fast is the graph growing? And our b value was our y-intercept. Where do we start the graph? This is our first easy dot, and then we'll follow the slope. Now, if I give you guys an example, y is equal to 2 over 3x, let's say plus 1, 2 over 3x plus 1. We have our slope, which is always in front of the x, and our y value, y-intercept is going to be our constant. This is 2 over 3, and our b value is equal to 1. Okay, so let's take a look at this right now. We are given a weird number and letter problem, and we're told in algebra that this has a relationship. Every time x changes, the answer y changes. So if x was big, y is probably going to get bigger in this case because they're both positive. So there's a positive relationship, and the slope is changing by 2/3. Here we go. Let's go ahead and draw this now and see that positive relationship. Our y-intercept is 1, so go up by 1, put a dot. So that's the big deal. That's our y-intercept, not our x-intercept. Some people, even on their final, we're graphing it over here. That is wrong. That's our x-intercept. So values that fall on the horizontal line here are going to be our x-intercept. And then the slope tells us our rise over run. Our rise over run, which is super cool because it's simple directions to get to my next point. Simple directions. So the rise will be up 1, 2, and we're going to run over 3. 1, 2, 3. Then we can draw a kind of line connecting them both. Hey, so the big deal here is that this equation can be re-represented as a line. And this line looks like it's rising, it's increasing. So imagine if this was a stock market. Would I invest in this stock? Yeah, I'm going to hop in because it looks like the value is going up. Okay. All right. As simple as that. Let's give ourselves one more problem. Y is equal to negative 3x plus 2. So my slope here is what, and what's my y-intercept? Go ahead and figure that out. Now, if you wrote negative 3x, remember, we do not carry the x with us. This is y goes to mx plus b. The x must stay, and only the number in front is my slope. Just as a quick reminder. And our b value is 2. We always describe slope as rise over run. Rise over run. So I'm going to put an invisible 1 here to make my life just a little bit easier. Just a little bit easier. So 3 over 1. You don't have to do that, but that should be going on in your head. Okay, we could say the slope is negative 1, 2, 3 over 1, but that's going to be wrong because we have to always start with our y-intercept. That tells us our first point to graph. So our y-intercept 1, 2, 3, 4, 1, 2, 3, going down, 1, 2, 3. Okay, so our first dot is going to be at 2. And the slope we're going to follow is negative 3, negative 1, 2, 3 down, and over 1 step. Now make sure you try that on your paper. You go down 3 steps, put your dot initially at the y-intercept 2, and then walk down, using your pencil, walk down 1, 2, 3 steps over, and then bump over by 1, 3 over 1. Put your second dot, and these two dots form our line. Do my best drawing a line there. Ish. Okay, so graphing stuff in slope-intercept form was actually one of our easiest ways of graphing it. But what if it wasn't in this form? So let's look at another very popular form that we had. And this next form was called standard form. That's an standard form. And this was when both x's and y's were on the same side. So let's say it's going to be ax plus by equals to c. Something like this, where the key point is that x and y, both variables x and y, are on the same side. While in slope-intercept form, it was always y was by itself. Y was by itself. Y was by itself. And that's one of the key elements. To get slope-intercept form, we would solve for y. Get y by itself. Now let's give ourselves a problem. Let's say 2x plus 3y is equal to 6. Okay? 2x plus 3y is equal to 6. Now we could graph this using what we called our intercepts, our x-intercept and y-intercept. But let's go ahead and first practice using some algebra moves to make this back into the slope-intercept form. Solve for y. So that's one of our skills right now. We're going to go ahead and solve for y. Let's get y by itself. We want this in slope-intercept form. We want to change this to become y equals to mx plus b. And this is a great practice of our algebra skills. Okay, as a reminder, to solve for y, we need to get rid of some stuff. There's a bunch of stuff here. There's a 2x and there's a 3. We need to ask these both to move over, get on over. We don't want you here anymore. Your stuff is getting moved out, getting kicked out. So do we get rid of the 2x first or the 3? If you remember the way I taught this in the first semester, get rid of the stuff that's farthest away from the variable you're trying to solve for. So if y is what I'm solving for, what's farthest away is the 2x. So what's opposite of plus 2x? We minus 2x to both sides. We're left with 3y is equal to negative 2x plus 6. 2x and 6 are not like terms, so we learned that we don't mix them together. That doesn't become 4. It's almost like carrots and apples and oranges. You don't mix them together, they're separate. Okay? No matter how round that apple is, they're not like terms. All right, our next move is to get rid of that 3. What is 3 doing to the y? 3 is multiplying that y. So the opposite of multiplication is division. So let's go ahead and divide that 3 over. And we can write it as one big division, which is 100% great. But I'm going to separate this into 2 easier division problems, because it's just from experience we find that it would be easier. Y is equal to negative 2 over 3 x plus, and 6 divided by 3 is 2. Great. Once we're in slope-intercept form again, we can graph this pretty quickly. Please tell me what the slope is, and please tell me what the y-intercept is for this problem. The slope is negative 2 over 3, and our y-intercept is 2. The cool thing again, that y-intercept tells us the first point we have to graph. Let's go ahead and set up the graph. 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. Just set up a quick graph. You don't need a grid paper, you know. Just do little tick marks. So again, let's go ahead and graph our first dot. Our first dot is going to be at y is 2. That's my 2 right here. Great. That's a dot. That's not a line. But the slope gives me the directions to my next point. So let's follow that slope. The slope goes negative 2, over 3. 1, 2, 3. Excellent. That's my next point right here. Since we have 2 lines, we can go ahead and 2 points, we can draw the line that connects them both. Now, let's go ahead and draw the same line. Well, okay, let's do some reflection here just to make sure we're good here. Is this line starting at my y-intercept 2? Yes, it is. Does this line grow or shrink? This line is shrinking essentially by 2 over 3. So we went down 1, 2, and 1, 2, 3. Yep, this is changing at a rate of 2/3, negative 2/3. Okay, we're going to do the same exact problem right now, except we're going to now do it with intercepts. We're going to solve the intercepts so for this in standard form. Okay, so here's our problem. So if you remember solving for x-intercepts and y-intercepts, x-intercepts and y-intercepts, the goal was, if I want to know what x is, we're going to make y 0. So x is what when y is equal to 0? And let's go ahead and plug that in. 2x plus 3, 0 is equal to 6 because y is now 0, which is great. 2x equals to 6. X is going to be 3 through division. And if you remember, I would just use my finger and I could just cover that up. If I just cover it up, 2x is 6. 2 times what is 6? This is one of our fastest ways to graph also, if it was an easy standard form problem. On the right side, if I want to find my y-intercept, if I'm looking for my y-intercept, what is y when x is 0? Right? So we can plug it in. 2 times 0 plus 3y equals to 6. Okay, great. This cancels out to become a 0. 3y is equal to 6. Y has to be 2 because 3 times 2 is 6. All right, I'm cool with that. Or if you remember the fast way, if I want to solve for y, I could block out the x with my finger. And what 3 times what is 6? 3 times y, 3 times 2 is 6. Y had to be 2. Now, if I want to graph it this way, let's go and take a look at graph. 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. This is 3, and this is, oops. Okay, so this is my y-intercept, and this is my x-intercept, and this is the same equation. So let's go ahead and graph this on the graph. For sure I know my y-intercept is 2. So my y value and my x value, my y-intercept is 2. We put a dot there. My x-intercept is 3. Put a dot there. And when we draw our line, this line should look exactly like our previous line up here. So if you take a look at your notes, whether we graph it in slope-intercept form or standard form using x and y intercepts, it's the same graph because it's the same exact equation. So whichever method you prefer, they're both going to get you the same way. Right? It's like your mom likes going through this way to the mall. You like going this way to the mall. Your dad has this way to the mall. You're all going to get there. But I'm going to tell you this. There is probably one person's method that's probably the best. It's probably going to be yours. So in math, there's a lot of ways of expressing a graph and our results. And our goal is to make sure that we understand what we find is the best for us, but also a reason why we like it. Okay, I like that. All right, so what we're going to do now is we're going to talk about a system of equations. So now that we've reviewed about graphing lines, let's do a system of equations. Now, when we talked about a system of equations, is that when I gave you two equations or two lines in general, these lines will have to eventually cross for the most part. Oops, let's use a different color there. So the red line and the black line eventually, in this case, are going to meet. And they're going to meet at this one point. So what does this one point refer to? We'll call this 3 and 1. At 3, 1, these points share a common point. So we can look at this as this is you, and this is your date. Oops, this is your date over here. You and your date. Now, do you guys have exactly the same schedules? No, right? Do you guys have exactly the same lives? No. Aren't you busy? Aren't they busy? But if you guys want to go on a date, if you guys want to meet someplace, you guys have to have a common point of time and location. So where is the only point on this whole graph that they can share some time? And you can see the only common point is at 3, 1. And that is a solution. But what are some other cases? So the solution here, solution, is at 3, 1. But is this the only case for these two people? Well, What if their lives were running in parallel? What if their lives were running in parallel? Would they ever have any time to meet? No. There is no solution here. And one more case, what if these people already were married and they're stuck in COVID together? Both these individuals would be stuck, on the same line, the same place. Are any of you guys practically bonded to your parents like glue? Like wherever they go, you go? So your dad calls, hey, where's your mom? Next to me. She calls you, where's the kid? Next to me. You're always stuck together. And if you're always stuck together, all these points are shared in common. And what do we call this? We call this infinitely many solutions. Infinitely many. That's an M. Solutions. We say infinitely many solutions because it means there are an infinity amount of solutions. Every single time these points touch, that's an answer. But aren't these lines exactly the same line? It's like, what was it, Hannah Montana? And Hannah Montana's alter ego was what? I forgot. Miley Cyrus played Hannah Montana. Oh, I forgot what it was. But remember, they were the same person, right? Okay, so we have three possibilities. We have one solution. We have no solutions, or we have infinitely many solutions. So depending on the shape, we can have other types of answers. But when it comes to line equations only, which is the scope of this class, line equations only. If I draw two lines, look at my arms, two lines. They can only meet either once, they can meet never at all, or they can be exactly the same line, which is infinitely many solutions. Let's go, what about if it was another shape? Yeah, if it was another shape, let's say this was a line and a parabola. Yes, that would have met twice. What if this was a line and a circle? A circle could meet none, it can meet once, or it can meet twice. So depending on the shapes that are interacting with each other, we end up with a different set of possible answers. But for us, in the scope of this class, we're just talking about lines here. And that's what the IXL work today will be about. It's going to ask how many answers are there? Is there one answer, zero answers, or infinitely many solutions? And you're going to be asked to graph these. So let's go ahead and look at our homework today through IXL. Okay, so here is a problem that we have. We're given the question, graph these equations. Click to select the point on the graph. So what that means is we're going to click our color here. If you take a look at the two different colors, I'm going to pick the y equals to 2x minus 2 first. Now we have to make sure we describe the correct characteristics. The slope here is in front of the x, which is 2, and the y-intercept is negative 2. So we first graph negative 2. I'm going to put a dot in negative 2. Whoops. Yeah, that's the right color. And the slope is going to be positive 2 over 1. So up 2 over 1. Let me zoom in a little bit for you guys. Up 2 over 1. Okay, that's my first line. Let's graph the second line. Y is negative 1. The y-intercept is negative 1. Put a dot in negative 1. And the slope is going to be up 7 over run 4. Rise 7. 1, 2, 3, 4, 5, 6, 7. And we're going to run 4. 1, 2, 3, 4. And you can see that these lines touch. They are not the same equation. Right? They have different y-intercepts. They have different slopes. But they do meet at one point. So another thing I want to point out is, are these lines parallel? Well, one slope is 2 and another slope is 7 over 4. These are not parallel lines. So we know for sure they have a solution. Now, do they have one solution or infinitely many? Well, if the lines are not exactly the same, they will only have one solution. Again, let me say this again. If the slopes are not the same, Okay, because if the slopes are the same, they would either be it would be no solution because they would be parallel. But if the equations were exactly the same, that would be infinitely many solutions because they're exactly the same equation. But in this case, they are not the same, so they only meet once. So let's go ahead and click one solution. Here we go, that's it. Excellent. Yay. We'll do it one more time. Y is equal to x minus 12. Oh, no, x minus 2. Let's go ahead and graph that. We're going to graph negative 2. Now, what is the slope in front of that x? It's an invisible 1. So we're going to write as up 1 over 1. That's how fast we can graph these lines. Our second equation, we're going to say y is equal to 2x plus 1. The plus 1 is my y-intercept. Let's put a dot there. And the slope would be rise over run, up 2 over 1. 1, 2 over 1. And as you can tell, these graphs meet at one point. Right? They meet at one point right here. Now, as a reminder, you can actually probably tell this automatically by looking at the equation. First, are the equations parallel? No. So for sure we have a solution. How many solutions? Well, the equations are not the same. So it's not going to be infinitely many solutions. It's only going to be one solution. As we can see in the picture, it's only one solution. The SATs kind of sometimes play with this, saying by looking at the equations themselves, how many solutions are there? Great work. Just as a reminder how to graph these variables without x, y is equal to 5. So let me ask you, which way is y? Is y going left to right or up and down? Isn't y going up and down? And that is the part that confuses kids. They think this is going to be up and down graph. Well, it's not. Let's get to y is 5. Y is 5 here. Y is 5 here, 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 here. Isn't y all 5? I don't care what your x is. It's like almost like I'm your parent. I don't care what your excuse is. I just care that y is 5. And take a look here, y is 5. So when you see y is equal to a number, that's actually not a vertical line. It's a horizontal line. It's almost like you saying, I'm on the 5th floor. I'm not telling you where in the building I'm at. I'm just saying I'm on the 5th floor. All I care is that you're on the 5th floor up here. Let's go ahead and look at our whoops, I graphed the wrong one. That was blue. That's supposed to be blue. Okay, let's go ahead and change this one. That's going to be y-intercept is 1. And the slope is negative 1 over 1. Negative 1 over 1. Negative 1 over 1. Okay, we have one solution. All right, let's go ahead and jump to a harder question here. Oh, I need to log in to do that. Whoops. I'm going to go ahead and log in. Okay, let's look at our next question here. We have one equation that's already in slope-intercept form, and the other one is not. It's in standard form. So we could graph it using its intercepts, but I'm going to go ahead and change this and rewrite it in slope-intercept form. Okay, so here we go. X minus 2y is equal to 6. We're going to solve for y here. So let's get rid of the x and the 2. I'm going to get rid of the x first because it's farthest away. Negative 2y is equal to negative x plus 6. Let's get rid of the 2. We're going to divide 2 to both sides. Negative 2 to both sides. I'm going to divide everyone by negative 2. Negative 2 divided by negative 2 is 1. That cancels out. Oops, let's use a different color. We have a negative become a positive. 1 over 2x, invisible 1 on top. And positive divided by negative is a negative 2. Right? Positive divided by negative is a negative. And 6 divided by 2 is 3. All right, so let's go ahead and graph this. Y is equal to 1/2 x minus 3. Y equals 1/2 x minus 3. Let's go ahead and put the minus 3 on the bottom here. Negative 3. And we said y is equal to 1/2. So up 1 over 2, 1/2. Let's go to graph the second equation. That's nice. They give me the in slope-intercept form. Y-intercept is negative 5. Slope is up 1 over 2. What do these lines look like? They look like they're parallel, aren't they? And as we mentioned before, the slope was positive 1/2. These are parallel lines. Parallel lines means these have no solutions here. Okay. All right. So hopefully those were enough examples for you guys to complete this IXL. If you guys have any more questions, please feel free to email me and ask me, okay?